In this video, I'm going to cover just about the first half of this Chapter 8 slideshow on lists. The lists we mentioned in the last video, saw a little bit about lists as the output of the built-in range function. I'm going to talk about how to create a list, how to access list elements, how to modify lists, how they work so well with the for loop structure. And then later on in another video, I'll talk a little bit about the way that lists are copied by default. It's a little bit tricky, so I'm going to take another video for that. What is a list? A list is a sequence of values. It's a data type. So an object can be a list, just like another object could be a string, another could be an integer, and so on. And strings are also sequences. We call them compound data types. They're a sequence of characters. So single numbers, letters, punctuation marks that can be described with ASCII. So lists can have any type of data object as their elements. So lists can contain strings, lists can contain integers, floating points, other lists. Values in a list are called its elements. Maybe you hear it called items in the list. Elements are separated by commas, and the entire sequence is started and ended with a square bracket. You can create a list just like with any other data type using an assign statement. So you'd have a 2-item list here, a single equal sign assigning that value to the variable called cities. It can be integers and it can be empty. Lists can be heterogeneous. So this is an example of a valid 4-item list. The first item, kind of the 0 index place, is the string hello. In the index 1 location, it's a floating point 2.0. Then there's the integer 5. And then there's what's called a nested 2-item list with 2 integers, 10 and 20. Empty lists are allowed and sometimes very useful or required for functions. I've got here a Python 2.7 session in idle. And if we run the bool function with an empty list, you see the output is false. Somewhat interestingly, if we run the bool function on a list that has an empty string in it, it's actually true. The string is false in the truthiness sense, but the list object itself does contain a string, albeit an empty string. We were introduced to lists using the range function. We saw that, I believe, with 2 arguments, and the range function can actually take 3. It's a little tricky in the order in which you type them, because you can call the range function with a single argument. Range 10 will produce a 10-item list, integers beginning with 0, ending with 9. And actually, the only argument here is the stop. So here, print out range 5, and there's the list that it produces. Now, if we put 2 arguments, it'll take the stop and the start. So range 2 to 5 gives us a 3-item list, integers 2, 3, 4. So including the start, but not including the stop. And then if we add a third parameter, we can set the step. So here, range 1, 2, 10. First 1 is the start. So we're not going to have a 0, which is the default. 10 will be the stop, not including 10. And the step will be 2. So starting on 1, stepping up 2 to 3 to 5 to 7 to 9. So when you're passing 3 arguments, it's start, stop, step, you can pass a single one, but it's not the first in the order, it's the stop. It's going to be a little tricky just to remember that. Just like with strings, we can use the bracket, integer bracket notation to reference items in a list using their index position. So this starting from left, going to right, starting at 0, up to 1, up to 2. And as with strings, we can also use negative integers to count index positions from the right. So there's no 0 here. That would give you the number 0. But in my list, -1 in this example gives you a 9. -2 would give an 8. -3 a 7, and so on. We saw in one example that lists can be nested. So in other words, one of the elements of this list, called list, variable name, is itself a list, 10 and 20 here. So that's the item in the number 3 index position. Sublist equals list 3. And if you think about it, if it's a list, it can have index positions itself. So here with these 3 lines, you can reference the number 10. You can do this in a little quicker or with fewer keystrokes by using 2 different indices. So list index 3 index 1 looks to the number 3 index item and then looks to the number 1 index item in that. So that would be the number 20. If you try to reference an item of a nested list in this way, but you refer to a non-nested list, in other words. So the index item 2 would be the integer 5. There is no indexed item in the number 5. So you would get a runtime error. In that case, if you were referencing the string, you could get a single number, which might give you a runtime error later on in your code, or could simply give you a semantic error in your output, some kind of different answer than you wanted. One characteristic about strings is that they're immutable, meaning you can't just change a single character of a string. We saw with that example, turning hello world to jello world, that you can kind of get around it by slicing up the input string and creating a new variable. But for lists, you don't even have to go to that trouble. They are mutable, and so you can assign new values to items in the list. Here, my list equals range 10. We get something like that. 10 items running from 0 to 9. The 7 position index is here is 6. I'm not sure that's accurate. This slide might be incorrect. But in this case, we can assign a value of 100 to that index. Change this back to 6. It's bothering me. If we assign a value of 100 to that index position, the list will be changed. So you'll note that my list, this is the same variable name. We don't have to do any kind of slicing or tricks like that. So individual elements of the list can be modified. Here's just some examples. List slicing here, or list replacement. So if we want to take a value that's 2 items, we can substitute multiple spots in the list. So if you remember from strings, the 1:3 index position refers to the item that is in the 1 position up to but not including the number 3. So it's the B and C here that's going to be dropped out. You can insert items rather than replace by using a subtly different index location. So 1:1. So that's referring to a location, but if we're including 1, but going up to, but not including 1, logically, it's not excluding anything. It's just placing it really right here. I'll move that arrow. And then if we print, we've got A, B, C, D, F. So a 5-item list each item is a single character string. If you try to just reference the number 1 rather than the position 1:1, it will insert it here. And actually, what will be inserted will be a 2-item list. Here, inserting a single item within a list to a position would get you A, B, C, D, E, F, like that. Now, if you only wanted to replace an element, you would not want the brackets. So if you're inserting something, you need a bracket into a list. You need to insert it as a list, even if it's just a 1-element list. Now here, if you wanted to replace something with the E, you wouldn't want these brackets. That would work. But this would be a little bit confusing. You'd still have a 5-item list, but the first 4 items here would be 1-character strings. The 5th wouldn't be a string, it would be a 1-item list, a nested list. If you wanted to delete elements in a list, you can do it in a couple ways. One here is to reference a range within the list that has items you want to delete and assign them an empty list as a value. So here 1:3, element index 1 up to but not including index 3. So we're going to target the B and the C. We assign them an empty list. The output list will be a 4-item ADEF string list. The other way you can delete is using this DEL delete operator. So here we're referencing del A1, the number 1 index position in A. So that would be here the string 2, TWO, delete it. You can delete more than one element in a list by referencing those using the colon notation in there. And just as we saw with strings, if you want to delete everything to the right of a certain position, you don't need to specify the end, just the start position and the colon. If you want to add elements to a list to the end, or I guess add new elements that would become the rightmost element, not kind of insert them at some intermediate position, there are 2 built-in functions you can use to do this: append and extend. So append adds a new element to the end of the list. T equals 3-item list, string A, B, C. Append string D, print that list again, and just as you might imagine, D is just added on to the end. If you want to append multiple elements in a second list to the first, you can use this extend. So ABC, extending that with DE, a 2-item list, would yield ABCDE. And the question here, would T1 append T2 work? Take a look at that. T1 equals list A, B, C. E2 equals list D, E. So T1 dot extend T2. Oh, print that. T1 dot extend T2. So the problem there was that Python wasn't evaluating this within the function, but it's actually changing T1. So it's got the DE, D twice. So I'll maybe get rid of that. Del T1 bracket 0, 1, 2, 3, 4, 5, colon. Now we'll print out T1 again. There we go, A, B, C, D, E. We'll bring T1 back to what it was before. T1, 3, colon. And now let's try the, as soon as I can get enough room right here, we'll try using append. T1 dot append, here we go. T1 dot append T2, T1. So this is a long way to show that when we use append to try to add multiple items, it's going to add them together as a single list. So what's the length of T1? We use the len function. It's 4. Even though we see 5 strings here, 2 of them are within this nested list. And so let's see. Can even check out the data type. For I in T1, print type I. Type is string, type is string, type is string, type is list. So string, 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 list, 4 elements. Back to here. So here, just examples of using a list. Lists make for loops very easy, but that's not to say that you can't use while loops to work through them. So here in this example function called print underscore colors, there's a 3-item list that's assigned to the variable colors. You think this might be a parameter situation, but oh well. Then the initialization of a looping variable called I, and then the use of that variable I in the condition of the while loop. So while I is less than 3, print the ith index of colors. So it starts at 0, so red gets printed. Then it increments by 1 to 1, green gets printed. Increments by 1 to 2, blue gets printed. Increments by 1 to 3, and then this condition is no longer true, so the while loop body is no longer executed. So you'll get red, green, blue printed. Now if we add yellow here, and don't modify the rest of the script, we'd still get the same output. Yellow wouldn't get printed unless we change the condition. So here's another example. If we try to use a different list, shapes, and print those out, we would need to change this, the value of the maximum in the condition. We do so by using the built-in ling function, len, ling. And here, instead of just writing out the list, we'll have the function take a list as an argument. And that's referenced here to figure out how many times to run the loop. And then again here to figure out which item to print. So you can do that with colors, shapes. It's robust to any list. It will print out all the items. Now that's a little bit easier to do in a for loop, as we saw. So define print list with a list as an argument for the looping variable. So it could be anything, x. Here we go. For x in list val, that has to be the same as the argument. Print the item and then space it by a tab. So note, if you have a nested list, the for loop is not going to go into that nest by itself. You could write a nested for loop if all of your items were going to be lists themselves. You could say for x in list val, and then within that, for y in x, and then it would loop through every single value. But as written, it would print out this entire list as 1. Lists are kind of amenable to certain mathematical operators, the plus and the times. So if you use the plus symbol, it's essentially like extending a list. A is a list 1, 2, 3. B is a list 4, 5, 6 integer. C equals A plus B. C is going to give you range 1 through 6. The multiplication involves a list operand and an integer, and what will happen is it'll get repeated. It's really the same thing as we saw with strings. So strings can be added to one another, not to integers, but to one another, and can be multiplied, in essence, just being repeated. So I'm going to wrap up this video here, and we'll do a separate video with more information on lists.